Hello, welcome to AB Video 3.78 Part 2, more optimization problems. Be able to find the derivative of the critical numbers and find the relative maxes and mins. Okay, this one's a little complicated. Find the point on the graph of the function that is closest to the given point. Closest means minimum distance, and the distance between 2 points is going to be the distance formula. So you've got a point on the curve, some random point xy, but sorry, in this case, this is like number 14. So here's your function, and here's your point. So if I draw a picture of this, just to not confuse you, so you know that this is a parabola turning up, and I moved it to the left one. So I don't know what those blue guys are, but I don't think I'm going to be able to get rid of them without getting rid of other stuff, but I shall try. Oh, not bad. There we go. Yeah, I don't know what that is. Okay. Okay, so there's our parabola. There's a random point on our parabola xy that is the closest point on our parabola to the point 5,3. So you can see it's not going to be over here. That's way further away. That's further away. I'm just picking that some random point xy, and I'm trying to say that that's the closest point to 5,3. But what is that random point? Okay, so the distance will be the distance between the point xy on the curve and the point why did I say negative 5,3? Oh, it's 5. Don't know where that negative came from. Let's delete that. Okay, and the point 5,3. Now, that point xy, keep in mind that your y on that graph is actually x plus 1 squared, so it's really the point x comma x plus 1 squared. So you have x2 minus x1 all squared, which is x minus 5 all squared, and then you have y2 minus y1 all squared. Now the distance is the square root. Now here's a trick of the trade. If you let d equal the square root, if you were doing this by hand, it would not be fun to take the derivative of this because of the square root. So what they do is they let s equal the contents of the radical, called the radicand, accepting the fact that the square root of something will be a minimum or a maximum when the thing inside it, the radicand, is a min or a max. Okay, the domain would be all real numbers because we have no idea where this point is going to be. Here's your equation, the derivative, the critical numbers, blah, 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 blah. Okay, you find out there's a min at 1, plug 1 into the original function, and you'll find that it's the 0.14. So it happens when x equals 1 and when y equals 4. Now, if you were to graph the actual distance equation, okay, on the calculator, you would get this graph, and you would get the y-coordinate is 4.12, which is actually the minimum distance. But if you graph the s version of it without the square root, what you're getting is the value of s, which is 17 as your minimum, and of course the square root of 17 is your 4.12. But 17 is not the minimum distance, it's the radicand of the minimum distance. Okay, this is like 22. You have, these are usually animal pens, and you have a rectangle. You're going to split it somewhere down here. Not necessarily in the middle, but you're going to split it so that these animals can't eat these animals. It's always a good plan. And so, obviously being rectangles, if this is x, this is also x, this is also x. If this is y, this is y. And you want to maximize the area. So you have so much fencing, okay? So you have a total perimeter of 200 feet of fencing. The blue all adds up to 200 feet. Now, of course, we're trying to maximize an area, so the area of the whole thing is y times x, but that's too many variables. I have a, x, and y. So we come back over here, and we realize that 3 of these x lengths plus 2 of these y lengths is this famous 200 feet of fencing that we have. Again, you can isolate x or y. I isolated y. I came over here, substituted it in, simplified it a little bit, simplified it a little bit more, and there's my actual function. Now, as far as my domain, since y has to be positive, then and y is 200 minus 3x over 2. Now, this is tough, okay? So if this has to be positive, then the numerator has to be positive because the denominator is 2. And that would mean that there is a limitation on this domain. X would have to be less than 200 over 3. I mean, think about it. You can't say X can be anything. So you have 200 feet of fencing, but X is 4,000. Well, that doesn't make any sense. Okay, so it's really a number array. Here's your function, of course. Here's your derivative, blah, 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 blah. You find out it happens when X is 100 over 3 feet and when Y is 50 feet.